Hello friends, welcome back to my channel Concepts of Telecom, Take It Easy. So today we are going to discuss about channels in LTE, that is physical, transport and logical channels. Okay, because it's really not easy to remember all those channels and there is always a confusion that which channel is which channel, like which is physical channel, which is transport channel and which is logical channel. Okay, so let's start. Okay, from here. Right. So first we will divide this section into two parts. One is downlink channels, and another one is uplink channels. So first we will discuss downlink channels. Okay. So actually there are three categories we can divide. The lowest level layer, we can say L1 layer, or we can say these channels physical channels. Okay, because we can say that this is uh, in physical layer, that's why they are physical channel. Then L2 layer is there, we can say that transport channels, and L3 is there, we can say them logical channels. So these are the three broad classification of channels: physical channel, transport channel and logical channel. So let's see how many physical channels are there. So if we will see, then we can start by uh, the first physical channel, we can say TDCCH, that is physical, because these are physical channels, so every channel will start with physical downlink. D stands for downlink. Control channel. Okay, so physical downlink control channel, this is PDCCH. Next one is PBCH. Obviously P stands for physical because it's a physical channel, so physical broadcast channel. Next is PDSCH. This is very important channel because most of the channels and the traffic, the data is linked on this channel. So how it is linked, that I'll explain later. So this is obviously physical, right? This is physical downlink shared channel, and since it is a shared channel, so this channel is shared by most of the logical channels and traffic channels. That's why it has most of the you can say data. So that's why it is very important channel, physical downlink shared channel. All the data, user data is carried on this channel, whatever data, uplink data or downlink, sorry, downlink only. Uplink we will talk later. Next is PCFICH. Okay, so obviously, so this is physical, stands for physical, and this is physical control, and 1 minute, it's transmitted through physical control format, right? This is physical control format. So this name you may find it a little bit strange. Format indicator channel, right? So basically we can say that this channel tells the format of PDCCH. Okay, because since this channel tells the format of PDCCH, that's why it is called physical control format indicator channel. Control format means this is a control channel, right? Physical downlink control channel, and this channel tells the control format indicator, that's why it's called PCFICH. Now the next one is PHICH, obviously physical hark. Okay, physical hark indicator channel, right? Now one channel is PMCH. Actually it is used for multicast services. PMCH, physical, so it is called physical multicast channel. Okay. Now obviously this HARC channel is used for HARC purposes, HARC flow, and this PMCH physical multicast channel. Multicast broadcast services are there. uh, okay, so these PMCH used for that channel. So now we are done with physical channel. Now the second layer, how many transport channels are there? Transport channel is PCH. Okay, now I'll tell you. Now second one is BCH and DLSCH and the MCH. Now see, these are transport channel. In transport channel we will not put physical, so this is paging. It is paging channel. P stands for paging. And we will not put physical because these are not physical channel, these are transport channel. This is broadcast channel. This is DLSCH, mean downlink shared channel. See, here it was physical downlink shared channel, here it was, right? And here it is downlink shared channel. Because it's not a physical channel, that's why we are not putting physical here. Downlink shared channel. Okay, this is multicast channel. Okay, now uppermost logical channels. So now PCCH. Okay, logical channels are of two types. What are the two types of logical channel? One are signaling channels and another one is transport channel. Okay, traffic channel we can say. So not transport channel, traffic channel and signaling channel. So we will see here. So this is PCCH. So this is, sorry, control channel and transport channel. Sorry, traffic channel. Logical channels are two types: control channel and traffic channel. So the channel which contains control information is called control channel, which contains traffic is called obviously traffic channel. So this is PCCH. PCCH stands for paging control channel. Okay, this is control channel. Paging control channel, right? Another one is BCCH, broadcast control channel, as the name is suggesting, right? Broadcast control channel. Okay, another one is CCCH, common control channel. These all are control channel, right? Another one is DCCH, dedicated control channel. Right, till now we have seen control channel in logical, right? Then there is DTCH. Okay, so DTCH is downlink traffic channel, we can say, right? DTCH we can say downlink traffic channel. Okay, so or whatever, like data transfer channel or downlink, this control channel we can say. Downlink, this is DTCH, dedicated traffic channel. Sorry, this is dedicated traffic channel. Okay, now the next one is MCCH. This is multicast control channel. Okay, another one is MTCH, multicast traffic channel. Okay, so now we can see in logical channels, this is traffic channel and this is traffic channel. Rest 1 2 3 4 5, these all are control channels. Now how is the mapping done, right? Now you see, this is paging control channel, right? So for mapping I'll take another color. this one. This is paging control channel. So paging control channel is mapped with paging channel, right? Paging channel, and this paging channel is mapped with PDSCH. Most of the channels are mapped with this PDSCH. I'll show you. That's why it is called physical downlink shared channel, because it is shared by many channels, right? So PCCH, paging control channel, is mapped with paging channel, and that is mapped with physical downlink shared channel. Now BCCH, okay, BCCH is broadcast control channel, and this is broadcast channel. So it is mapped with this, right? Okay, and this is physical broadcast channel. So this is broadcast control channel, this is broadcast channel, and it is physical broadcast channel, so it is mapped with PBCH here. Okay, next one is CCCH, common control channel. Common control channel is mapped with downlink shared channel, right? So because it's a shared channel, right? So most of the channels are mapped with this as well. So this is downlink shared channel, and this is dedicated control channel. It is also mapped with this. Then it is DTCH, dedicated traffic channel. It is also mapped with this. Then it is multicast control channel, right? Multicast control channel is also mapped with this. MTCH, MTCH is mapped with both, and MCH, multicast channel, right? So we can say CCCH, DCCH, DTCH, MCCH, and MTCH all are mapped with downlink shared channel. Only two are mapped with different. And here also BCCH is also mapped with this. It is BCCH is mapped with downlink shared channel and BCH both. Because one thing you can remember, then here in BCH, here MIB is transferred, MIB, and there SIB is transferred. So I'll tell you later, actually these are master information block and system information block. So this is one thing to remember, you should memorize it, because this, it could be a question anywhere, that on which channel the MIB is transferred. So you should say that it is transferred on broadcast control channel and BCCH, and then PBCH, physical broadcast channel. On this way the MIB is transferred, right? And the SIB is transferred through downlink shared channel. Both are transferred by this broadcast control channel, but MIB is transferred on this way and SIB is transferred on this way. Now, obviously, if we will map from transport channel to physical channel, so obviously it will map with this. Definitely, this is downlink shared channel and it's physical downlink shared channel, right? And this MTCH, multicast channel, so it is mapped with this one, PMCH, right? So that's it, all mapping has been done, and these channels are not mapped with any transport channel or logical channels, because these are uh, like informative in information channels, right? Information means these are just indicator channels, like this PDCCH, so it contains DCI, downlink control information. Okay, this is PDCCH, it contains downlink control information, and it is control format information, and it contains HARC information, right? So these three channels are not mapped with any channel, and this is how is the mapping of all downlink channels. Okay, this is physical, the lowest layer, this is transport, and these are logical channel are two types, control and traffic. Okay, so now let's see about what this. Now the downlink has been covered. Now we will see uplink, right? How the uplink is there. So for uplink channel, it's very easy to remember, because in uplink channel there are not many channels. 1 minute, huh? Okay, so for uplink, if we will see, uplink is obviously physical. Okay, sorry, I'll take this one. Physical transport logical. Okay, so physical is one is PRACH. You might have heard about this PRACH. If not, I'll tell you. Another one is PUSCH. See, here in downlink channel, you saw that there is a PDSCH, right? This one, physical downlink shared channel. So this is the counterpart, we can say, of uplink, physical uplink shared channel. It has most of the information, right? Another one is PUCCH. PUCCH, and this PUCCH we can say is the counterpart of this one, PDSCH. This is physical downlink control channel, and it is physical uplink control channel. It has control information of uplink, and it has control information of downlink. Now, how the mapping transport channels are of uplink ULSCH, like it was in downlink DLSCH. So it is uplink shared channel. Okay, this is physical uplink, right, shared channel. This is physical uplink control channel, right? This is physical RACH, means random access channel. Okay, now the third one in logical, we have CCCH, as it was in downlink as well, common control channel. DCCH, dedicated control channel. DTCH, dedicated traffic channel. All these channels we were having in downlink as well. Okay, so this is how it is mapped, all three here, and this one is mapped here, right? And these are not mapped anywhere, PRACH and PUCCH. It has the information of PRACH, has the information of RACH, random access channel, right? Through PRACH only the UE is tries to send the preamble and try to what you can say, get the RRC connection. Okay, that I'll explain later in messages flow. This is RACH, and this is UCI. It is used for UCI, as the this one used for DCI, downlink control information. It is used for UCI, uplink control information. So in uplink only these are the channels, right? So it's very easy in uplink and not much complication, right? So these are the channels for downlink and uplink, and it's really easy. I mean, it's really not difficult to memorize them. You just have to draw it yourself 2-3 times and write all the names on some paper, and you will easily memorize it. And almost all this names and all are very easy to memorize, right? Abbreviations are very easy. Okay, so now since one of our friend requested for covering some questions of LT, question answers of LT, and that's I really like that, because we should also cover some questions and answers of LT that could be asked in some interview. So it is a really very good initiative. I mean, somebody asked me to do so, so I'm covering today here two questions. I will cover two questions in every session. So question number one: what is PCI? It is a very general question. What is PCI and how it is calculated, right? PCI. What is PCI? PCI is physical channel indicator, you can say, physical channel identity, you can say. Okay, and how it is calculated? The formula for PCI is sorry, the formula for PCI is 3 into physical channel group. Remember this formula, you should memorize it, plus cell id, physical cell id you can say, or okay, physical cell id you can say. So what happens that PCI is calculated, or some you may find some formula here, 3 into SSS plus PSS. What is this SSS? SSS is secondary synchronization, okay, primary synchronization signal and secondary synchronization signal, secondary synchronization signal, and PSS is primary synchronization signal. Now what happens that why are we showing PSS and SSS? Because it is the same thing, because SSS contains this information, physical channel group ID, and PSS contains this information. So it's just a way of writing this, that PCI is equal to 3 into physical channel group ID plus cell ID, or 3 into SSS and PSS cell. And what is this? I will mean very briefly I'll explain what is PSS and FSS. Whenever you power on your UE first time, okay, when you power on your UE first time, then what happens that it first of all it tries to latch with the network, right? It goes for registration and all, so it tries to latch for the network. So what happens that it scans the what you can say MIB, that is the primary synchronization signal and secondary synchronization signal, right? MIB and SIB. So these are two informations, primary synchronization signal and secondary synchronization signal. So MIB contains physical group, right? PSS, SSS, then MIB and all, SIB. So this is called physical group ID, and this is cell ID. It has cell ID. So this is just the brief introduction of this, what is PSS and SSS, right? So it contains this one. So this is how it is calculated. This according to the formula, that 3 into this SSS plus PSS. Now, how many SSS are there in LTE? Okay, this may be the question, that what is how many PCIs are there in the LTE? So in SSS there are 0 to 163. Okay, SSS cell group ID possible. So 3 into plus 0 1 2, right? 3 cell IDs are possible. So how much it comes? So it comes to total 3 into 1 sorry see, this is 167, right? So it comes to 168, okay, plus 0 1 2. So how many types would be possible? So types would be possible 3 into this 168. So total 504 PCI are possible in LTE, right? Possible in LTE. In LTE 504 PCIs are possible. You should memorize this formula. This is a very general question in any LTE interview, it could be, right? And just for information, since I have not started yet 5G, but for information, just in 5G, just for information I'm telling you, this number in 5G, it is 336, just double. So the total PCIs in 5Gs are just double, so it is 1008 in 5G. Okay, in 5G 1008 PCIs are possible, and in 4G 504. Fine. Okay, so this is one question. You should memorize it, and you understand the formula, that how it is calculated. One more question, question number 2. I will cover that how many preambles are there in LTE. Preambles, you understand? Preambles are whenever you first power on the UE, right? In that you send, there are 0 to, I'll tell you, there are 0 to 64 preambles are there, right? So 0 to 53 are contention based, You should remember it. The 0 to 53 are contention based and 54 to 64 are contention free. So whenever a UE sends a RACH request, a random access channel, so that is sent with a preamble. So these are those preambles. Whenever the first time UE sends a RACH request for attach this for getting the RRC connection to the E node B, so out of these 64, one preamble is used by the UE. Right, out of these 60 0 to 64, 0 to 53 are contention based, and 54 to 63 are contention free preambles. So these are just two questions, important questions. I mean, so I'll cover slowly. We will cover two questions, and those are enough. If you uh, like understand those the questions, the answers of those, I mean, you slowly you can develop very good knowledge of LT and 5G. So thank you, friends, and hope I'll put my another video soon. Thank you very much.